pressure equals to 1/3 N upon V mv square, right? So after studying the derivation for the pressure of an ideal gas, then we studied some important derivation, that is those are root mean square velocity, that is RMS velocity, is it? So root mean square velocity, which is given by the formula VRMS equals to under root 3RT upon M0, under root 3RT upon M0. After studying this formula, then we studied the interpretation of temperature in kinetic theory. So interpretation of temperature, what did we found? So energy equals to total energy equals to temperature, means it depends on the temperature that we derive. For that again we used the formula for the pressure. What is formula for the pressure? P equals to 1/3 N upon V into mv square. So here what arrangement we did? P means for finding out the relation between total energy, we introduced half mv square. For introducing the half, we are supposed to multiply by 2 and divide by 2, right? Those steps we perform. Finally, what we got? So, in interpretation of temperature in kinetic theory, we got E upon N equals to 3 by 2. E upon N equals to 3 by 2 kb into T. It means E upon N, energy, total energy upon number of molecule, total energy equals to what? 3 by 2 kb into T. Kb is the Boltzmann constant. Capital T is the absolute temperature. It does mean that the energy depends upon the absolute temperature. Means whenever we measure temperature of gas, that time it is nothing but we measure the total energy of the gas molecules. Clear? So after studying the interpretation of temperature in kinetic theory, then we studied specific heat capacity, Cp and Cv. If the volume is kept constant and if heat is supplied to the gas, so that its temperature increases by 1 degree Kelvin. So for that, how much gas we have taken? 1 mole of gas. So whatever amount of heat is required to raise the temperature of the gas by 1 degree, that amount of heat is called as a specific heat of constant volume. Specific heat, molar specific heat at constant volume, Cv. For molar specific heat, that is a dQ1. Whatever heat is added, we assume that dQ1. dQ1 equals to how much? What we get? dQ1 is nothing but dE. That is change in internal energy. After that, this change in internal energy is nothing but Cv dt. Means molar specific heat at constant volume into dt. dt means change in temperature. Got it? Then we studied Cp. What is this Cp? Cp is nothing but molar specific heat at constant pressure. Molar specific heat of a gas at constant pressure. And how it is to be found? For that, we have to keep pressure constant. How the pressure is kept constant? For that, we used cylinder and piston arrangement. The movable, frictionless piston. Assume that this movable frictionless piston has, we have kept a constant weight on a pan so that pressure remains constant. If the pressure is kept constant, then after heating, what will happen? If the gas is heated by maintaining the pressure constant, what happens? Here, internal energy of the gas also increases as well as work is performed. Means piston is slided by little bit distance. Okay. So piston slides. And that's why due to that sliding, the work is performed. Because work is known to you. Work means what? Force into displacement. So piston gets displaced. So that's why there is a change in work. dW means dQ2. Q2 क्या है? Heat supplied. dQ2 equals to dW plus dE plus dW, right? So by putting here the value and doing some arrangement and all, what we get? We get one relation, Cp minus Cv equals to capital R. Okay, Cp minus Cv equals to R, and this is Mayer's relation. Okay, this is Mayer's relation between specific heats. But after studying this relation, then Cp minus Cv equals to R upon J. Capital J is what? That is Joule's mechanical equivalent of heat. R upon J. J means what? Joule's mechanical equivalent of heat. Right? So this part we studied. I'll show you what thing we studied yesterday. I repeat what we studied. For that, I'm showing the things which we studied yesterday. See, this part we studied. Okay. So here dQ1 equals to dE equals to Cv dt. Right. Cv is the molar specific heat of the gas. Okay, at constant volume. Okay, okay, wait for a while. Okay, so this thing already we studied yesterday. Excuse me, एक minute screen. If you cannot see the screen carefully, just I want to do some area arrangement. Wait. Okay. Okay. Now, so yesterday we studied this part. dQ1 equals to what? dQ1 is nothing but a D, that is heat supplied to the gas by maintaining constant of volume dQ1, that is dE means Cv dt. dt means what? Change in temperature. Cv is what? That is molar specific heat of a gas at constant of volume. Clear? Then I told you, if we put pressure constant, then the amount of heat is utilized in change in internal energy plus change in work done. This equals to Cp dt. Now instead of dE, what we have to substitute? This relation, that is Cv dt. So you just to put this. So instead of this, that is Cv dt, dq2 cv dt plus dw equals to cp dt. Clear? Then cp dt equals to cv dt plus dw. Finally, cp minus cv into dt equals to pdv. Clear? For 1 mole of gas, pv equals to RT. pdv equals to rdt. Is it? Because volume के बदले हमने क्या किया? We took dv. And instead of T, what we took? dt, that is change in temperature. So pdv equals to rdt. Since pressure is a constant, pressure is constant, right? So that's why Cp minus Cv into dt equals to rdt. Finally, we got Cp minus Cv equals to R. This is known as what? This is known as Mayer's relation between Cp and Cv. The above relation has been derived assuming that the heat energy and mechanical work are measured in the same unit. Generally, heat supplied is measured in calories and work done is measured in joules. The above relation that is modified to Cp minus Cv equals to R upon J. J क्या है? J is mechanical equivalent of heat. Also, Cp equals to M0 into Sp and Cv equals to M0 into Sv, where M0 is the molar mass of the gas and Sv and Sp and Sv are respective principal specific heat, not molar specific heat. Sp and Sv are respective specific heats, principal specific heat, not molar. So finally what we get? Many books. Okay. Then M0 Sv minus M0 Sp minus M0 Sv equals to R upon J. By taking M0 common from this, M0 अगर दोनों में से कॉमन निकल दिया और इधर शिफ्ट किया तो व्हाट वी गेट? Sp minus Sv. Sp minus Sv, this is the Sp is the specific heat. Sv is the specific heat at constant volume. R upon M0 into J. R upon J पहले है ही. अब क्या हो गया कि M0 भी shifted अब in this direction. So it is divided to the R. Clear? So up to this we studied. Then we studied, I shared this problem with you. After sharing this problem, the next important part is monoatomic gases. Monoatomic gases ज़्यादा डिटेल में जाने की जरूरत नहीं है. In case of monoatomic, actually in all these monoatomic, diatomic and polyatomic gases. Monoatomic gas मतलब क्या? कि single atom, only single atom is there, like as a argon. So in case of argon, what we are supposed to find, that is gamma. Gamma का मतलब क्या है? Gamma is Cp upon Cv. Gamma is nothing but a adiabatic heat index. Adiabatic index gamma. Formula क्या है gamma का? Cp upon Cv. तो in all these cases, Cp equals to phi upon 2 R. Cv equals to 3 by 2 R. Cp equals to pi upon 2 R. If we divide this, that is gamma. For gamma, if we divide Cp and Cv, what we get? Phi upon 3. For monoatomic gas, gamma का है एडियाबैटिक इंडेक्स. इसका मतलब क्या है? Cp upon Cv. This equals to phi upon 3 for monoatomic gases. Diatomic gases का मतलब क्या है? कि only two molecules are there. Then diatomic gases. In case of diatomic gases, means this is the entire derivation. It is not necessary to study thoroughly. Like in for your knowledge, you can study it afterwards. So gamma comes 7 upon 5. In case of what? Diatomic gases, like as a carbon dioxide, HCl, hydrochloric acid, na? N2, nitrogen, O2, oxygen. These are diatomic gases. For these diatomic gases, the Cp upon Cv relation gamma equals to how much? 7 upon 5 आता है. How it comes 7 upon 5, that thing is explained here. But you don't use your concentration, more concentration for studying this. इसको सिर्फ याद रखो आप. डायटोमिक गैसेस है तो डायटोमिक गैसेस के लिए गैमा का वैल्यू सी पे अपॉन सीवी कितना आता है? 7 अपॉन 5. डायटोमिक गैसेस गैमा का वैल्यू कितना है? 7 अपॉन 5. मोनो एटोमिक गैसेस गैमा का वैल्यू कितना है? 5 अपॉन 3. इज इट? देन पॉली एटोमिक गैसेस, सॉरी, डायटोमिक गैसेस का सीपी अपॉन सीवी फॉर्मूला कितना आता है? 9 अपॉन 7. ये ध्यान में रखना है आपको. मोनो एटोमिक का सीपी अपॉन सीवी कितना आता है? हाउ मच इट कम्स? 5 अपॉन 3. डायटोमिक का सीपी अपॉन सीवी हाउ मच इट कम्स? 9 अपॉन 7. ये ध्यान में रखना है. मोनो एटोमिक 5/3 and for diatomic 9 upon 7. This much easy part is there. Now, after studying the part up to this, then the polyatomic gases. Both are a derivation here, but it is not necessary to study thoroughly. Finally, what we get? The ratio, that is gamma Cp upon Cv equals to 4 plus F upon 3 plus F. F क्या है? This is degree of freedom. That is removed from your syllabus. So do not worry about this derivation. Right? So up to this we studied. Now let us move our concentration on the next part of this chapter, that is called as a radiation. Okay. So now let us start radiation. For that I am going to share my screen with you. मैं अपना स्क्रीन अभी आपके साथ शेयर करने जा रहा हूं. Okay, see, I'm going to share my screen. Okay. See, now let us start the next part, that is called as a radiation part of this chapter, which is very interesting part, and very fast we can study this part because already we studied heat transfer and mode of heat transfer and all this, right? No, so that's why it is very easy part. See, for that I'm going to share one page with you. See, here are some questions. So read them. First question is, what are the different modes of transfer of heat? Can you tell me what are the different modes of transfer of heat? Come on, tell me if someone knows what are the different modes of transfer of heat. What are the different modes of transfer of heat? If someone knows, please give me answer.
Conduction,
Yes, conduction,
convection,
convection, and radiation. Correct. Good. So these are the different modes of heat transfer. Now, when the heat flows heat transfers from higher temperature body to lower temperature body, or higher temperature region to the lower temperature region. Okay, so there are three modes of heat transfer: conduction, convection, radiation. For conduction, we need a material medium. उसके लिए हमें material medium का बहुत जरूरी है. Whether it may be solid, liquid, whatever, but we need a material medium for conduction. जैसे कि एक हमारे पास कोई मेटल का एक रॉड है, एंड इफ द मेटल रॉड इज हीटेड फ्रॉम लेफ्ट साइडिंग, automatically it gets heated, and finally we get a entire heated rod. Means the heat transfer takes place from left to right. अगर हम मेटल रॉड को लेफ्ट साइड में